All right. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to start our review for the final exam. And my goal for today is just to focus on the first objective, or call it the first chapter if you want, that we did way back at the beginning of the quarter. And I have in front of us the chapter review. My plan is to just go through and work each of those problems. If in doing so, you find that you want more examples of a certain type of problem, say so, and we'll go into more detail there. Or if there's some explanation that you're not sure about. But anyway, the next 5 class days, I'm going to go through objectives 1, 2, 3, 4, and 5. And then I will come back and go through the chapter tests, doing the same thing with the remaining days. Okay, so let me get a blank screen here. This first question, it says round 6. Come on. There we go. 673.363 to the nearest hundred. Now, careful, it doesn't say hundredth, it says hundred. This is the ones, the tens, and the hundreds column. So this is the column where we're going to do the rounding. So we go one column to the right, which is going to be the 7. 5 and above rounds up, 4 and below rounds down. So the 7 is going to round up. So we would get what? 700? 700? And there we see our answer. Any questions about that? Do you want more examples of this particular type of problem? Okay. Well, I guess it doesn't matter if we put the answer in there or not, but so we'll go on to the next question. This is another rounding question. Round 47.23625 to the nearest 100,000th. Well, this is tens, ones, tenths, hundredths, thousandths, 10,000ths, 100,000ths. So the 4 is in the 100,000ths column. Again, tenths, hundredths, thousandths, 10,000ths, 100,000ths. We go one digit to the right. The 5 rounds up. So we get 47.23625 because the 4 would round up one place. Okay. And there we see the answer. 47.23625. Good to go on? Tell you what, I'll just keep going unless you stop me, and I'll quit asking. Are we okay? Is everybody got it? All right. This is number 3. It says round 166.742 to the nearest 10th. Not 10, but 10th. So this is the 10th column. The 4 would round down, so we get 166.7. Okay. Going on to question number 4. Round 189.545 to the nearest whole number. Sometimes this confuses people. What would a whole number be? Well, it would be with no decimal, right? So this would be the place you would round, the ones place. The 5 would round up, which would turn this 9 into a 10, which would then carry over to the 8, so we get 190. And there's our answer. Okay. All right. So now we're moving on from rounding to translating a sentence or a statement into an algebraic expression, it says to use X for the variable. 25 more than 3 times a number. 25 more than. So we're adding 25 to something. More than what? 3 times a number. The number is what we're going to call X. So we're going to get 3X and then plus 25. Okay. Any question? Oh, I wasn't going to ask that. Sorry. Okay. It's a habit. Question 6. Translate the following into an algebraic expression. 31 less than. So 31 less than something. The product of 9 and a number. So the product of 9 and a number would be 9 times X. 31 less than that. So we end up with 9X minus 31. 9X minus 31. Okay. All right, let's go on to number 7. It says, find 73 decreased by 42. So 73 decreased by 42. So translate to mathematical symbols. 73 decreased by 42. The result is, well, let's see, 73 minus 42 is 31. And let's see, use parentheses only when necessary. Here's where it tells the symbol to use for multiplication, which we didn't need in this example anyway, though. All righty. If I'm going too fast, let me know. Find the product of 3 and 22. Product is multiplication, so we've got 3 times 22. So 3 times 22. Again, it says to use the asterisk as multiplication. And the result is going to be 66. Okay. Number 9, what is the quotient of 56 and 7? Quotient means to divide. So we've got 56 divided by 7. And it says to use this symbol for division. So 56 divided by 7, which is 8. For those of you that just got here, basically, I'm going through the chapter review from the first chapter. If you have any questions beyond what I'm doing here, please say, hey, could you do another one of those? Or how did you do that? Or what do you mean by that? This is your time. All righty. Well, it's all your time. But anyway, let's take a look now. Now we're looking at order of operations problems. So we've got negative 15 plus negative 14. Adding 2 numbers with the same sign, add their absolute values, and attach the common sign. So the answer would be negative 29. Okay. Number 11. Evaluate 4 plus negative 15. When adding 2 numbers with different signs, subtract the smaller absolute value from the larger absolute value. Let's see here. This is going to be 4. This is going to be 15. So subtract the smaller absolute value from the larger absolute value. Then go back and attach the sign of the number that had the largest absolute value. This one had the largest absolute value and it was negative. So final answer, negative 11. Any questions about that one? Okay. Let's see here. Number 12. Evaluate 8 minus 15. And again, you could do this on your calculator. And if you have calculator questions, as I've said before, please ask. But doing it without the calculator, subtraction can be changed to addition of the opposite. Now the problem is just like the previous one, adding two numbers with different signs. We're going to find the difference. And what we're going to do is subtract the smaller absolute value from the larger, and then attach the sign of the number with the largest absolute value. So final answer, negative 7. But again, if you can look at this and just go 8 minus 15, I know that we're in the whole 7 units, negative 7, then you don't have to go through all these steps. But this is just if you need that for the process. Okay. Oops. All right, let's take a look at number 13. Evaluate negative 8 minus negative 23. Well, subtracting can be changed into addition of the opposite. So what I'm going to do here, I'm going to change my ink color. Subtracting a negative is like adding a positive.
Is there going to be a review for the final exam, or is this it?
That's what we're going to be doing from now till the end of the quarter. Yes, this is,
Okay.
yeah, we're going to go through objectives 1, 2, 3, 4, and 5 over the next 5 class days. Then I'm going to go back and spend time going through the chapter tests. Yeah, so this is it. This is the beginning of the review for the final. All right.
Okay, thank you.
You betcha. All right, so we've got negative 8 plus 23. So we're adding two numbers with different signs. Whoops. Come on. Let's see here. We're going to subtract the smaller absolute value from the larger absolute value. Then we'll attach the sign of the number with the largest absolute value. So it's going to be a positive 15 or just 15. Number 14 coming up, negative 6 minus 8 minus negative 3 plus 30. I could rewrite this as negative 6 plus negative 8 plus positive 3 plus 30. Addition is commutative, so I can add these numbers in any order I want. Adding the two negatives, I get negative 14. Adding the two positives, I get a positive 33. So I now have negative 14 plus 33. I'm adding two numbers with opposite signs or different signs. So I'm going to find the difference. Take the absolute values of each, subtract the smaller absolute value from the larger. I get 19. Attach the sign of the number with the largest absolute value, and it was positive. So I get just plain old 19. We good to go with that one? All right. And again, if I go past one too quickly and you need me to back it up, let me know. 15, evaluate negative 3 times 3 times negative 4. Negative 3 times 3 would be negative 9. Negative 9 times negative 4 would be positive 36. I'm multiplying a bunch of numbers together, if I have an even number of negative factors, the answer is positive. An odd number, the answer is negative. So I could go through and say, well, there's 2 negative factors, which is even. So now I know the answer is positive, and 3 times 3 is 9, times 4 is 36. Divide. Negative divided by negative is positive. So let's see, 224 divided by 16 goes in once and then 4 times. So it goes in exactly 14 times. Again, it's positive because negative divided by negative is positive. Number 17, simplified. The exponent is a 2, which means we're going to multiply together 2 factors of the base. The base is -6. The negative is included inside the parentheses. So this is -6 times -6, which would be positive 36. Now, contrasting that with problem 18, however, here, the exponent is a 2, so you want 2 factors of the base, but the base is just the 3 because the negative is not included. It's as if though it were written like that. So this is a negative, or think of it as like a -1 times 3 squared, -1 times 3 times 3, -1 times 9, -9, final answer. Again, any questions about the difference between 17 and 18? Okay, we'll go on to 19 then. Change 55/7 to a mixed number or whole number when applicable, however you say that. So to do that, I'm going to use long division. Let's see, 7 times 7 is 49 with a remainder of 6. So it's going to be 7 6/7. Okay. Let's see, 7 and 6/7. I want to do something here just to make sure, because I have a feeling if I do it this way, it's going to be wrong. If I don't use the stuff down here and I go 7 and then space 6/7. Let's see if that marks that right. Error. Yeah, it doesn't like that. So in this problem, you have to use the notation down below. Just wanted to make note of that. Okay. Now it says, yeah, okay, but here we can see that it's correct. All right. Number 20, change 5 1/6 into an improper fraction. So here we're going the other direction. 5 1/6. So we take 5 times 6, which is 30, plus the 1, which is 31 all over 6. So 5 times 6 is 30, plus 1 all over 6. So 31 over 6. Now, I can do just a single fraction using the slant key or whatever you call it there. Okay. Number 21, write the fraction in lowest terms. Well, there's a couple of different ways we can do this. We can use the prime factorization of each number. 18 is 2 times 9, which is 2 times 3 times 3. 63 is 9 times 7, which is 3 times 3 times 7. So we could do it that way, and then come back in and say, well, 3 over 3 reduces to 1 over 1, and 3 over 3 reduces to 1 over 1, and we have 2 7s. So that is one way to do this problem. That way will always work. Another way to do it, I sort of call this the chip away method. You look at it and you see, can you think of a number that's a factor of both 18 and 63? And if you happen to come up with 9, then you divide the top and the bottom both by 9, you get there. And then you say, well, are there any other common factors of 2 and 7? The answer is no, so you get there. Now, the second method, this way, was a lot quicker, but sometimes it's not obvious to see what are common factors. So this way will always get you there, even though sometimes it is longer. 2, let's see, divided by 7. Okay. And continuing on. Again, if you have questions, please stop me. Add 4 3/10 plus 6 1/10 and write the result as a mixed number or whole number. 4 3/10 plus 6 1/10. We could add the whole numbers and get 10. We could add the fractions. 3/10 plus 1/10 is 4/10. However, we can reduce 4/10 down to 2/5. So the answer would be 10 2/5. And as we learned earlier, we have to use this. So 2/5. All right, let's go on to 23. Add 1/3 plus 11/15 plus 1/5. To add fractions, we need a common denominator. The least common denominator of 3, 15, and 5 is 15. Is everybody okay with me just jumping to that, or do you need me to go through how to find that it's 15? Okay. (11/15) is still 11/15. Change the color here to red. So 1/3, if I multiply by 5/5, I get 5/15. 1/5, if I multiply by 3/3, I get 3/15. So now 5/15 plus 11/15 is 16/15, plus 3/15 is 19/15. Now, it says write the result in simplified form. It doesn't say whether to write it as a fraction or a mixed number. Let's see what it's got there. It's got a mixed number. I want to try something first. I'm going to put the fraction in and see if it accepts it. And it does. Okay. Now let's use the mixed number. Let's see, 1 4/15. And it also accepts that. So because it didn't specify which type to use, it accepted both of them. I refer you back to earlier, let's see here, where was it? There were some places where it said to use a mixed number or an improper fraction. Oh, well, maybe it's, It's coming up later. Sorry. It's when I was looking this over before we started class. All right, my bad. 24. Add 8 5/6 plus 8 4/15 and write the result as a mixed number. So first of all, I can add the 8 and the 8 and get 16, but to add the 5/6 and the 4/15, I need a common denominator. So I need the least common denominator of 6 and 15. The prime factorization of 6 is 2 times 3. The prime factorization of 15 is 3 times 5. The least common denominator is the product of the highest power of each different prime factor within any of the given denominators. So I've got 2 to the 1 power times 3 to the 1 power times 5 to the 1 power. I don't need 2 3s. If 2 3s were in a single factor or in a single denominator, then I would. But so 2 times 3 times 5, 6 times 5, 30. So the LCD is 30. So this becomes 8 and so many 30ths plus 8 and so many 30ths. I'm going to multiply 5/6 by 5/5 to get 25 30ths. I'm going to multiply 4/15 by 2/2 to get 8 30ths. So now 8 plus 8 is 16. 25 30ths plus 8 30ths is 33 30ths. But I wouldn't leave a mixed number like this. I need to take the 33 30ths and change it into what? 1 and 3 30ths, which would be 1 and 1/10, adding that to the 16. So I get 17 and 1/10. All right, let's go through this again. I needed a common denominator of 30, so I changed these to where they were 30ths. That gave me 33 30ths, which became 1 and 3 30ths, but I can reduce 3 30ths to 1/10. So this became 1 and 1/10 added to 16, 17 and 1/10. And here it says to write the result as a mixed number. So an improper fraction would not be correct here. 1/10. Alrighty. Let's take a look at problem number 25. Subtract 9/15 minus 4/15. Subtracting two numbers with the same denominator. Subtract the numerators over the common denominator. But that can be reduced down to 1/3 by dividing the top and the bottom both by 5. All right, going on. Number 26, subtract -5/6 minus -3/4. Well, I need to get a common denominator, but I also can kind of clean up my subtraction problem. And what I'm going to do is rewrite subtraction as addition of the opposite. So what that gets me is -5/6 plus 3/4. Okay. Common denominator of 6 and 4. 6, the prime factorization is 2 times 3. 4, the prime factorization is 2 times 2. So the LCD is going to be 2 squared times 3, because here I have 2 squared. So that's the highest power of 2 between these. Okay, so that's what 4 times 3 is 12. So I'm going to multiply -5/6 by 2 over 2 to get -10/12. Multiply 3/4 by 3 over 3 to get 9/12. -10/12 plus 9/12. -10 plus 9 would be what? -1. So -1/12. -1/12. Oh. Oh, I wrote it in the wrong place. I thought, what? Okay. Not a good thing. I've seen that happen to students as well. I wasn't paying enough attention. -1.
I've done that.
Have you? And it's really a bummer when it's a test and you can't.
Right?
So I always tell people, before you push that submit question, check your work carefully. Yeah, okay. 27 coming up. Subtract 3 3/10 minus 1 31/50. Okay. I can take 1 away from 3 and get 2, but to take 31/50 away from 3/10, I can't do that. I need a common denominator. So what's the least common denominator of 10 and 50? Anybody know just off the top of your head? Okay.
50.
What's that?
Is it 50?
Yes, it's 50. So you'd have 2 times 5 squared, right? Because you'd have the highest power of 2, which is just 1, the highest power of 5, which is 5 squared. So 50. So. And let's see here. Oh, this we don't have to do anything to. And let's see here. We're going to change the ink color. So I'm going to multiply by 5 over 5, which is going to give me that. And I see that I copied something incorrectly. So let's fix that. This should be a 1, right? Okay. Well, I can't take 31 away from 15, so I have to borrow. Not necessarily the quickest way, but the easiest way at this point to talk about how to do this would be to change both of them into improper fractions, okay? So 3 15/50 would be 3 times 50, which is 150, plus 15, which is 165 over 50. Okay? Minus 1 times 50 is 50, plus 31 is 81/50. Still with me?
Yep.
So now we're going to take 165 minus 81, which is 84. So we get 84/50. I see that I can reduce that because they're both even. So that'd be what, 42 over 25. But it says to write the result as a mixed number or proper fraction. So I can't leave it as an improper fraction. 42 divided by 25 is going to be 1. And let's see, borrow and carry, that's a 7 and a 1, 17/25. So 1 and 17/25. 1 and 17/25. Now, before I push submit, I'm going to double check things here. 3/10, 15/50, 105, 165, 81, 84, 42, 25, 25. I believe that is correct. Okay. Oh, there it is. I guess that's cheating. Looking at it before I submit it, huh? You don't have that luxury. Okay. That's the advantage I have as the teacher.
Aren't the test answers in the later meeting?
Oh yeah. You guys didn't know about that? That's why nobody comes to the afternoon session where I give all the answers away. Now everybody will show up and they'll be so disappointed that I just lied. Okay, but Eric started it, so that's all that matters. All right, blame him. 28. Simplify the expression. 29 minus 4 times 6. So we're back to order of operations. We do what? Grouping symbols like parentheses or absolute value bars, brackets, braces, fraction bars. Then we do exponents. Then we do multiplication or division, whichever comes first from left to right. And then addition or subtraction, whichever comes first from left to right. So in this case, we're going to do the multiplication before the subtraction. And 29 minus 24 is 5. Okay. $29, 7 minus 2, the quantity, times 5. So here we would do what's inside the grouping symbol first. 7 minus 2 is 5. So we have 5 times 5, or 25. Number 30. Simplify the expression. 54 divided by 6 minus 5. We would do division before subtraction. 54 divided by 6 is 9, and 9 minus 5 is 4. $31, we have 24 divided by the quantity, 5 minus 2. We would do inside the parentheses first. 24 divided by 5 minus 2 is 3. 24 divided by 3 is a positive 8. $32, 6 squared plus 13 all over the quantity 9 minus 2 squared. The fraction bar is a grouping symbol separating the numerator from the denominator. We'll start with a numerator. We would do the exponent before the addition. 6 times 6 is 36. Then the addition, 36 plus 13 is 49. In the denominator, we would do inside the parentheses before the exponent. 9 minus 2 is 7. 7 squared is 49. And now 49 divided by 49 is 1. Right. 33, simplify the expression. 8 squared minus 12 plus 24 divided by 6. We have an exponent, subtraction, addition, and division. We would do the exponent first. 8 times 8 is 64. Then we would do multiplication or division, whichever comes first. before addition and subtraction. 24 divided by 6 is 4. Then we do addition and subtraction from left to right. Well, 64 minus 12 is 52. And 52 plus 4 is 56. So our final answer should be 56. Number 34, simplify the expression 9 squared minus the quantity 19 plus 49 divided by 7. We would start inside the grouping symbol, and inside the grouping symbol, we would do the division before the addition. 49 divided by 7 is 7. Then continuing inside the grouping symbol, 19 plus 7 is 26. Finally, we would do the exponent before the subtraction. 81 minus 26, we borrow and carry. 11 minus 6 is 5. 7 minus 2 is 5. So we should get 55 as our final answer. What have we got here? Let's see, we got 42. And we're going to make it, I hope. All right. 35, negative 6 squared minus 9 squared. So this is negative 36 minus 81, which is negative 36 plus negative 81, changing subtraction into addition of the opposite, adding two numbers with the same sign, add their absolute values, and attach the common sign. Number 36, evaluate 4y minus 6t, where y is negative 3 and t is negative 5. Whenever we replace a variable with its equal number, we're going to put parentheses around it. So I've got 4 times negative 3 minus 6 times negative 5. 4 times negative 3 is negative 12 minus 6 times negative 5 is negative 30. But subtracting a negative is like adding a positive. So I've got negative 12 plus 30. Adding two numbers with opposite signs. Subtract the smaller absolute value from the larger absolute value. And then attach the sign of the number that had the largest absolute value, which was a positive. So I get a positive 18, which I'm just going to write as 18. This next question, as I recall, a lot of people missed this kind of question on the test. So let's see here. Negative the absolute value of 2a minus g plus the absolute value of negative 6x, where a is negative 6, g is also negative 6, and x is negative 5. So we're going to get negative the absolute value of 2 times negative 6 minus negative 6 plus the absolute value of negative 6 times negative 5. All right, we simplify what's inside absolute value bars before we do the absolute value. So let's see here. I've got 2 times negative 6 minus negative 6. Subtracting a negative would be like adding a positive. 2 times negative 6 is negative 12. So I've got negative 12 plus 6, which would be negative 6. Okay, so simplifying all the way inside, I'd have negative 6 inside. But the absolute value of negative 6 is a positive 6 outside. and then this negative sign on the outside attaches to it. Plus, -6 times -5 would be +30, still inside. Absolute value of 30 would be 30 outside. -6 plus 30 would be what? 30 minus 6 is 24, and it's going to be positive. Okay. 38. Multiply and simplify. 27 over 7 times 35 over 45. We can reduce, for instance, 35 over 7 reduces down to 5 over 1. 5 over 45 reduces down to 1 over 9. 27 over 9 reduces to 3 over 1. And so we end up with a final answer of 3. $39. Multiply and simplify. -2/3 times 8/18. Well, let's see. 2 over 18 is 1 over 9. 8 is 2 times 2 times 2, and 9 is 3 times 3. So there's no more common factors. So basically, that's all I can do. So -8 divided by 27. Okay. Whether 42, yeah, we're going to make it. We're going to make it. Okay. Number 40. Okay, number 40. Multiply and simplify. 2 and 1/9 times 11 and 1/4. Recall that when you're going to multiply mixed numbers, you have to change them into improper fractions. So 2 and 1/9, 2 times 9 is 18 plus 1 is 19/9. 11 and 1/4, 11 times 4 is 44 plus 1 is 45/4. These are being multiplied. 45 over 9 is 5 over 1. 19 is prime, 5 is prime, 4 is 2 times 2, and there's no common factor of a 2 in the top and the bottom. 19 times 5 is 95 over 4. Now, notice the instructions, not mixed numbers. So 95 divided by 4. Okay. But if you put a mixed number in here, even if it's the correct mixed number, you didn't follow the directions and it marks it wrong. Okay. And then people write me a note and say, isn't it right? No, you didn't follow directions. Okay. 41. 5/4 divided by -25 over 28. Dividing by a number is like multiplying by its reciprocal. Okay. 5 over 25 is 1 over 5. 28 over 4 is 7 over 1. The negative sign is still intact, so I've got -7/5. Now, I could rewrite that as -1 2/5, but the directions say not mixed numbers. -7/5. Okay. And finally, oops, I ran out of slides. I guess we'll do it down here. Number 42, we have 2 and 11/12 divided by 1 and 1/4. So first of all, I need to change the mixed numbers into improper fractions. 2 times 12 is 24 plus 11 would be 35 twelfths, divided by 1 times 4 is 4, plus 1 is 5 fourths. But that's going to be 35 twelfths times 4 fifths, right? Dividing by a number, multiplying by its reciprocal. 35 over 5, 7 over 1, 4 over 12, 1 over 3, 7 thirds. Don't use a mixed number, so we put in 7 thirds, and there we go. Well, I missed one because I wasn't paying attention. Put it in the wrong place, but otherwise we did okay. All right, so tomorrow, actually tomorrow is Saturday. Monday, I'll be back with, we'll do the same thing with a chapter 2 review. And as I say, as we're going through these, if anybody has questions, they can stop me. If they want to look at other examples, I can always, get a similar question, et cetera, et cetera. I will be back this afternoon at 1:15 with an office hour. Otherwise, have a great weekend. Yes, and I'll see you on Monday, if not before.